Hi everyone, welcome to Communication Systems course ENGI 28779. This is your first course in system level communications. System level, what it means is that you are looking at it with the lens of an electrical engineer. You want to see how the different components that are required in building a communication systems are put together, are assembled, how they function, how the signal moves and changes from one form to another, and that's what it means system level. And we will look at it in a very modular way where we look at it from different components and different systems with inputs and outputs and so on. And so that's the big picture of this course. The course is split into two parts. The first part is analog communication, and the next part is the second part is digital communication. Of course, digital is more relevant to what's happening today, but it is designed this way so that you appreciate how we moved from analog communication to digital communication. And the various analog communications that we will show you in the first part are actually technologies that still exist, albeit unwinding gradually, such as AM and FM communication, but still they are around. Okay, so the point of this first lecture is essentially to explain to you how we will operate this course. This is the first time that we are offering this course online. This is not an online course. This is a course that we need to be in the lab. We want to be involved with different equipments as we go and perform this course. So of course we have theory, but we also have a big hands-on component to it. At this point, because of where we are, we cannot access the labs, and therefore we are offering it online. And as we're doing this, we want to kind of show you how we will operate the course, the logistics of that, and how the hands-on practical component is somehow translated into other means, and we'll explain that as we move along. Okay, so let's get going. Okay, so in this slide, we will discuss the course logistics. Like I said before, the course is known as Communication Systems, ENGI 28779. This is a 4-semester course. The general prerequisite is Digital Principles 1. This is a 4-semester course, so you've taken a bunch of courses before coming here, and you should have a baggage of knowledge that will be useful. But in general, Digital Principles 1 is key to move on with at least the second part of the course, the digital part. I am your instructor, so my name is Mohammed Abdullah. I'm a professor of electrical engineering at Sheridan School of Mechanical and Electrical Engineering Technology within the faculty of FAST. I believe some of you know who I am. I've already was your instructor for either technical writing and presentation or electrical fundamentals, because I was looking at some of the names and the names are familiar. So if you are, if we know each other, then that's great. But if you don't know who I am, this is my name. I connected my website on SLATE, so you could go there and see what my background and so on. Now, the program that this is offered for, it's offered in the Electronics Engineering Technology program, and so if you're sitting here, you're electrical engineering students. We do not have computer engineering students taking this course. Computer engineering students, they have a wireless communication course, not the wireless communication systems course. So for electronic students and electrical students, we have two key courses: Communication Systems course and Wireless Communication Systems course. Both of them I teach. And on the computer side, we have a wireless communication course. It's more of an upper layer course, and that's taught by Weijing for those students in computer. This semester, this is the summer 2020 semester. The semester will move from May 19 to August 14. So we did not begin on May 18. It was a holiday, so we began on Tuesday of this week, and we're going to go all the way to August 14. Altogether, if you look at it, this will form 12 weeks. So you have 6 weeks break, and then another 6 weeks, and that's what we will have here. The credits that you get after successfully finishing this course is 4 credits. Now, I have to say this is not a trivial course. This is not an easy course, as some would say. It will take some effort. You need to be active in it. You need to do the problems, and you need to work hard on it. This course is not a course that you could just move along. You really need to do some work in order to do well in the course. So I hope everybody is energized and you are ready to begin with this course. Now, the sections that I am involved in the teaching are the following. So these are the sections. And this is the same people that sit in each section, but this is the lab section for them. And this is it. So I am your instructor for the first part, for 6A semester, that is from week 1 to week 6. And then from week 7 to week 12, you will have Lamia and Barry that will continue and teach you that. So I'll focus mostly on analog communication. They will focus on digital communication. Here I simply wanted to kind of talk about SLATE. You are 4th semester students, so I presume many of you are very familiar with SLATE. We do not survive Sheridan without SLATE. We use it for everything. Even before COVID, we always rely on it, but now with COVID, we are relying on it even more so. So in case we have some students that forgot, so SLATE stands for Sheridan's Learning and Teaching Environment. The way to log in, I certainly hope everybody knows this link by now, but the way to log in is this link here, and you put in your username and password, and once you log in, you should look for the course ID ENGI 28779. Once you go there, on that page, this will be the main landing page for this course. So every section will have their own kind of landing page for this course. And in that page, I post all the stuff related to the course, including slides, labs, grades, everything will be there. Assignments, everything should be there. Also, the evaluations that we will do in this course, because we're doing all the evaluations online, it will be on SLATE by going there. So I do spend some time on SLATE to make it look good and make it look efficient and easy for students to navigate. So I hope when you log in, you take advantage of it. So sometimes SLATE by some instructors is done in a very, it's not done effectively, but here I try to really spend time to make it as effective and as friendly as possible for the students. So I hope you certainly find your way with that. If you are returning students that know my style, I guess you will know how I operate with SLATE. On SLATE, I will also put the announcements. So we will have a lot of announcements because we're not teaching you in a physical classroom. We are doing this virtually, so announcements will be necessary. So please check your SLATEs regularly for the announcements. And also, if you need to email me, please use SLATE to email me. You could also email your colleagues, so you have all the names there if you're doing group work and so on. But we don't have a mandatory group work here. Not even the labs are group work. I'll explain later on. The course delivery. How are we going to deliver the course? So in the class plan, which I uploaded to SLATE, you have all the details there, but I will try to explain it here on this slide. So one thing you should be reminded is that the dates and activities in the outline can change, right? We do have a course outline. It is a contract between you and I, or you and me on this, but everything could change. I have to move with the limitation of the number of lectures that I have, and also with the pace of students. So according to that, we'll see how to operate that. So some of the topics could be relaxed, some of them could be removed. We'll see. So we already lost 2 weeks. Instead of 14 weeks, we have 12 weeks. So we'll see how that goes. But in general, we will try to stick to what you have on the course outline that I've outlined there, which you can access as a PDF document on SLATE. It's also available on my website. You could download it there. So the lectures, the way we will deliver the lectures is through recorded means. So I will record the lectures and post it on YouTube. And some might say, why are we doing this? Because there are other means of delivering the lecture. Here I'm going to list 4 reasons why I like to do a recorded lecture. Number 1, it avoids overloading the virtual classroom capability of SLATE. We have a lot of professors and teachers using SLATE throughout the day, and it could overload it, and it makes it non-responsive. So there is that risk, and so we want to avoid that. Number 2, it provides students the capability to go through the lecture at flexible days and times. We know we are in challenging times. Students can perhaps be working, or they might have some health challenges or some family constraints, so they might not be available at every single time. So we don't want to put pressure on them because of all that is going on. So we want to give it flexible for them to come in at any day, any time that they prefer. Turn on the video, listen to the lecture. If they get tired, they could just pause it or turn it off, come back to it the next day, or whenever they can. So it adds a degree of flexibility. The third reason why we're doing recorded lectures is that it helps students navigate topics at their own pace. So if you look at a topic and you have more difficulty, you could always rewind and play it again. If you still have difficulty, you can always rewind and play it again. Or if a topic is trivial for you, you understand it, you've seen it somewhere else, you are knowledgeable on it, you don't want to waste time on it, you could certainly fast forward and move on to topics that are perhaps less familiar. So you could navigate at your own pace and at your own speed and at your own learning skill set. So there's that advantage. The fourth reason why we opted to go with recorded lectures is that it overcomes lost lectures due to holidays. So this semester we have 2 Mondays that are lost, and I have 2 sections that I teach on Monday. So May 18, if we would have done it as a live lecture, it would have been lost. Because of Victoria Day, and August 3rd, it would have also been lost because of the Civic Day. So we're already at 12 weeks. We lose 2 other weeks, so that brings us to 10 weeks. So instead of rescheduling and finding and all that, putting it as a recorded lecture will be much easier. It will save us those lost days. So how do you access the lectures? Well, the lectures are posted on YouTube, so this is the link to go there. You could, for instance, subscribe, and subscribing will enable you to be notified when a new video is released. You should also, after subscribing, press the bell icon, and this will notify you once a video is released. Of course, you want to have access to YouTube, and for YouTube, you need a Gmail account. So that's the requirement that is needed here. In addition to videos posted online, we will have a live office hour. So this is an actual virtual classroom In this classroom, I won't be necessarily teaching you. I will be there to listen to some of your questions. So if you have questions, if you have concerns, if you have issues, if you need more clarification, I'll be there to go through that. And it's more of a kind of a we all come together as a community. So I specifically selected a day and time that works for everybody. Because of the I saw the master plan, the master schedule for all the students, and this should not be a conflict with anyone. So attending the live office hour is not mandatory, but if you want to attend, you could certainly attend. It will be on a Tuesday from 10 a.m. to 11 a.m. So it's a 1 hour block. It's live. You could come in with your questions, and then we could just go over it over there. Now, of course, if you have questions related to the lab is based on doing it on your own. So I cannot solve the lab for you. But if you have some general, generic questions that I could tell you, we could certainly go through it. You could also bring some of your concerns or questions related to how are we going to operate exams and so on, or how certain topics will show up on an evaluation, things like that. We could discuss it there. So it should be interesting. It should also be fun. It's social, and it enables us to actually discuss all that in one space, virtually, but all that not in one space, but virtually, all together. So the class should be for all the sections. So this should bring together some 80 so students together. So the first session for the first live office session will begin next week, week 2. And I'll provide you the details of how to connect to it on SLATE. So stay on the look for that. Now, also, if you need to see me in addition to this live office hour for a private one-on-one interaction, you could certainly send me an email. Please do not use the email on my website or my Sheridan email. Use the email through SLATE. So that's the best way that I will do that. So if you use the other emails, unfortunately, I will not answer because it will not reach me. So use the email on SLATE, and that's the best way to get a hold of me. And if we need to move beyond email in certain circumstances, we will be able to do that. You have my extension, so it's here, and we could do that. But don't begin by calling me first. If you have a concern, send me an email, and if need be, we might move it into a Cisco WebEx interaction or a phone call. Okay. The grading scheme is one key question that I get all the time from students. They want to know how it's done. So all this, of course, is in the class plan, which is on SLATE. But I will go through it here so you'll see how we are breaking down the grading scheme for the semester. So number one, we will have exams, of course. We have two major evaluations. We have the midterm test. The midterm test will be in the first half, so just before your break week in week 6. It's worth 30%, and the duration that you have to do this test is 90 minutes. You will have a final exam as well, and this is in the second half. This is in your last week, week 12. And also it's of duration of 90 minutes. So both of them together, that's your 60%. We also have quizzes. In the past, when we taught this course in face-to-face format, we used to have 2 quizzes, but now that we're teaching it online, we wanted to reduce the value for the number of labs and also the weight of labs, and so we decided to increase the number of quizzes. So that's one reason, because we're teaching it online. And the other reason why we increased the number of quizzes is that we wanted to really prepare you for the midterm and the final. So you'll have 2 quizzes before your midterm, and you'll have 2 quizzes before your final, and this should in principle aid you when you go there. So the quizzes, they're worth 5% each. And the first quiz will be in week 3, the second quiz will be in week 5, the third quiz will be in week 8, and the fourth quiz in week 10. And then what is covered for the midterm and for the quiz, all that is explained later on. I'll just show it to you later on so you'll know what it is. But in general, you should be mindful that quizzes are 15 minutes, so they're very short, multiple choice questions that you have. And that's it. So you'll get 4 choices. You pick the one that you think is the most appropriate, and then you move on. And in principle, after you finish answering the multiple choice question, you'll get the result right away. All this midterm, final quizzes, all of it will be administered using the quiz tool on SLATE, and I'll explain it later on. We will also have labs. Of course, we cannot proceed with face-to-face, hands-on labs in the lab with a spectrum analyzer, with an oscilloscope, filters, and so on. We have to do it, mixers, filters, and so on. We have to do it using other means, and we will conduct labs, but these labs will be based on simulations. So we'll explain that to you in a bit. And so in principle, we will have 8 labs, and the labs are worth 2.5% each, and so you'll have. So we do have a lab 0. I'll upload that soon to SLATE, probably tonight. And lab 0 is basically just the steps that you need to follow in order to download MATLAB. That's what it is. There's no marks for it. As for the other labs, they are worth 2.5% of your semester. So here we go. And you'll have a lab in week 2, 3, 4, 5. Week 6, there's no lab. That's going to be your midterm. Then week 7, 8, 9, 10, you'll have labs. Week 11, week 12, there's no labs. Okay. Now, you should know that we will follow the dual pass provision. And many of you know what it is. You've been at Sheridan for some time, and you've had courses with me. So we usually have dual pass provision in my courses. What it means is you need to pass the exam component by itself, and so you need to at least get 30 out of 60 for the midterm and the final, and you need to get at least 20 out of 40 for the lab and quizzes. So even if, let's say, you get a mark that is perhaps above 50, that does not guarantee a pass. So for instance, you get 40 out of 40 for the quizzes in the lab, so you do very well here, you do very well here, you get a perfect mark, 40 out of 40, and you get 10 out of 60 for the exams. Unfortunately, that's a fail. Right? You really have to show that you've passed this component on its own and this component on its own. If both are a pass, then you pass a course. Otherwise, then the one is unsuccessful in the class. Assignments, we have assignments. I already uploaded assignments to SLATE, so I uploaded the assignments for the first half of the semester, 4 assignments. These assignment questions are really for you, to help you. So they kind of give you a sense and a flavor of how the evaluations will be. They give you kind of a peek of how the midterm will be, how the final will be. And then I'll provide you answer keys to them later on. But for now, I want you to try them on your own after we've, of course, covered the concepts, the theory. Then you'll be able to practice them. I strongly, you see I repeated it 3 times, suggest that you go through the assignments. They will certainly help you with your with the quizzes and with these evaluations. They will also help you with labs as well. So I strongly suggest that you do that, and I think that will be in your favor to go through the assignment questions. Sometimes because there's no marks, students will not pay attention to it, and that's where the danger is. You should actually pay attention to it. Okay, and as for your progress, well, you should monitor your own progress, right? The grades will be posted on SLATE regularly, so you're adults, and you should monitor your own progress to see how you're doing in the semester. Okay, academic integrity. So I'm sure you're familiar with this, but I have to reiterate what it means and what does academic integrity mean, especially in the context of work, doing evaluations at home when nobody is there to see what you're doing. Well, not quite, but I'll explain. So all submitted work must be originally performed by you, by the students, right? So you cannot take something that you found online or that you are copying from someone. This is just not permitted. It will not follow academic integrity. Quizzes, midterm, final must be performed individually, right? So you cannot, the whole point is that we want to see how you perform. And that's the whole point of taking these evaluations. Any academic integrity violation will be treated seriously. So as you know, Sheridan is very, very strict, and especially in our school, we are extremely strict on following academic integrity. So any breaches, plagiarized work, there's going to be major consequences for that. So please pay attention to this. Also, if you need to familiarize yourself with your rights as a student in regards to academic integrity and what it means and so on, Sheridan has a nice website here where there's a lot of description there. It's filled with resources and information for you if you are curious about it. Now, for us, because we are conducting the evaluations online, we will apply two different tools to safeguard against plagiarism and dishonesty in doing your evaluation. The first tool that we will use is the Respondus lockdown browser. So essentially what it means is that once you begin an evaluation, you cannot open another browser to look for things online. So it just locks your browser and it does not allow you to check your email or go to another website. So that's the first one, and you need to install it before the evaluation. In fact, when you begin an evaluation, it will prompt you to follow that. The other thing that we will use is the Respondus monitor. So what this does is that there's a camera that monitors you as you're doing your evaluation. So it will record you throughout your evaluation, and we have invigilators and also the instructor, myself. We will be monitoring the performance of students in order to make sure that no plagiarism is occurring. You should also show your ID and also show the surrounding that you're in, and then you could begin working. So that's another approach to safeguard against plagiarism. So just be mindful that we will be using both of them this semester. Okay, the evaluation platform, I think I hinted on this so far, but as you know, we will use the quiz tool on SLATE in order to do the quizzes, the midterm, and the final exam. In fact, we won't only just use the quiz tool, we will use the quiz tool and the assignment tool on SLATE. The assignment tool will be necessary in order to submit in addition to what you will submit using the quiz tool. You need to submit your handwritten work for the midterm in the final, and for these two we will use the assignment tool. The requirement means that you will need a computer, and in fact we do recommend a computer, an actual computer, not a handheld device, not a tablet, not a cell phone. It will not give you the best experience. You really need to have an actual computer, whether it's a desktop or most likely most of you have your laptop. You also need a webcam. You could most devices, laptop machines, you have an integrated camera with the screen. But if that's non-functional or there's something wrong with it, or simply you don't have one, you have an older machine, then you will need to buy a webcam. They don't cost too much. I think they're around $10 to $20 Canadian. So you'll need to get that, and you have to make sure that it is functional. Don't configure this on the day of the midterm or the final. You have to configure and test it way before that. You also, of course, need to have internet connectivity. So this table, I did it yesterday. I was trying to kind of explain to you how the evaluations will be. So number one, you have in this column all the evaluations. So the first half, this is what you will do with me, and then this is the second half. This is what you will do with the Lamia and with Barry. So in the first half, you'll have quiz 1 and quiz 2 and the midterm. In the second half, you'll have quiz 3, quiz 4, and the final. This is the weight of each of the evaluation. These are the dates for your evaluations. So right away, you know this. So your quiz 1 will be on Tuesday, June 2nd, from 10:30 a.m. until 11 a.m. And your quiz 2 will be the same thing, June 16th from 10:30 a.m. until 11 a.m. And your midterm will be on June 23rd from 9 a.m. until 11 a.m. Now, and then the same thing here, right? It's similar here. You have the dates there. Availability. What does availability mean? It means that you have a window, a really short window, a 5-minute window for you to log into SLATE and then to log into the evaluation. So you have to be ready as soon as the tool allows you to log in, which is 10:30 a.m., to log in as soon as possible. So you have a 5-minute window to log into the exam. If you log in at 10:36 or 10:37, this is it. It's passed and you cannot log in and we cannot do anything for you. So there's a 5-minute window in order for you to log in. So make sure you're there on time so that you don't get into trouble here. Okay, so this is what it means. Availability is 5-minute window. So for quizzes, we give you a 5-minute window. For the midterm, we give you a 10-minute window. So anywhere between 9 and 9:10, you'll be able to log in. You come in at 9:11 or 9:12 or 9:13, forget it. You cannot log in. You come in at 10:36, 10:37, 10:38, 10:40, forget it. You cannot log in, and unfortunately, that will lead to a 0. So you have to be mindful of this. So 5-minute window for quizzes, 10-minute window for midterm and final. Now, after you log in, once you log in, then a timer will begin. And once you log in, irrespective of where you logged in here, a timer will begin and you'll see the timer on the top left corner. Probably you already did this with other courses. You'll see a timer. And for the quizzes, like I said, you'll have 15 minutes and then you'll have a bunch of multiple choice questions that you need to solve. And for the midterm as well. Okay. In fact, the midterm as well will be multiple choice questions. So you'll have multiple choice questions in the midterm, and then a select number of questions, in addition to providing a multiple choice answer, will require that you submit a handwritten work. So you can these multiple choice questions, don't think they're easy because they're multiple choice questions. That you will need to do work. You need to actually take your calculator, your brain, your pen, and do some work, and then come up with a result. The result and the work that you do on the paper, we want to see it, right? So you will then put all the work that we ask you to here to put it all together as a single PDF and upload it to SLATE in the assignment tool. You'll have 15 minutes to digitize your work and upload it as an assignment. So if you see a grade from midterm after taking your midterm, this is the upper grade that you get. After monitoring and checking your handwritten work, this grade could go down because maybe you plagiarize, right? So that's another way to safeguard against plagiarism. So this 15-minute window is to digitize your work, i.e. to take picture of your work, of your handwritten work if you don't have a scanner, and then to put it on Word and print it to PDF and upload the PDF to SLATE. What else? Here we have the remote proctoring approach that we use. So for the quizzes, like I said, we have B. B stands for Respondus Lockdown Browser. It's just a shorthand notation that I put here because I didn't have space to write it. So we will use the Lockdown Browser, Lockdown Browser, Lockdown Browser, Lockdown Browser. And for the midterm and the final, we will use both Lockdown Browser and the Respondus Monitor. So this is the tool that we use to safeguard against your plagiarism. So if you see for the big ones, for the midterm and the final, in order to check that no plagiarism happened, we will use the Lockdown Browser, we will use the Respondus Monitor, and we will also check that your work is done by you, because you will do the steps. Your handwritten work is not just the letter that you selected in the multiple choice question. Okay. So I hope this is clear. Probably I will explain it again, but this is kind of the bulk of what it is. So this is an important table. You really need to keep track of these dates. I did post all these dates already on your calendar on SLATE, so you should be notified automatically. But this page is important to keep with. Okay, so in here we will talk about the laboratory work and the deliverable that you have to do when you will undertake laboratory work. So as noted earlier, we do have 8 labs. Each lab is worth 2.5% of the final grade, and if you multiply them together, that adds up to 20%. All the labs should be conducted individually. So sometimes when we're in school at Sheridan and we're in a lab environment, we have all the hardware in front of us, we allow you to work in teams, and then you submit a team report. Here, since we are physically distanced from each other, and it's a software-based work, we will ask that every person will do their own work individually. You do it, you finish it, and you submit it on SLATE. So the work, as hinted on multiple occasions in this lecture, we will not be hardware-based, but rather software-based, and we will do simulations of communication systems, very basic communication systems. This is your first course in system-level communication, so the simulations will be quite basic. And we will use a combination. Essentially, the tool that we will use is referred to as MATLAB. It's a very famous tool. It has a lot of wide reach. Most universities and colleges use MATLAB. Companies, people that work in companies, they also use MATLAB. It's very powerful, and so we will be using this. We are fortunate as faculty and students of Sheridan because we do have the license, and you do not need to pay for this software, so it's available free of charge for you to install. I'll explain the installation in a sec. And so we'll use a combination of MATLAB and Simulink. So MATLAB installation, essentially, just very briefly, it will be explained to you in Lab 0. So again, Lab 0 has no marks. It's just the steps of how to install MATLAB. I will upload it to SLATE, and you'll see the details of how to do it. But in general, if you want to do it on your own, you basically need to go to Apps Anywhere. So I think most of you know Apps Anywhere. It's a mechanism that we have at Sheridan where we could download applications no matter where we are. And once you go to Apps Anywhere, you'll be able to locate MATLAB, and then you'll be able to download it. Once you click on download, it will essentially bring you to the MathWorks website. MathWorks is a company of MATLAB, and over there you need to create credentials and then download MATLAB. Once you download MATLAB, at some point in the installation, it will ask you to select the toolboxes that you need in the installation. Just make sure that you select Simulink, DSP System Toolbox. DSP stands for Digital Signal Processing, and the Communication Toolbox. So make sure you put a check mark next to these 3 toolboxes. These toolboxes are the different applications within MATLAB that we will utilize, right? So Simulink is part of MATLAB, and MATLAB is kind of the main application. Now, the lab handouts. So the labs, to be honest, we don't have them. We're just working on them right now. We did not have simulation-based labs. So the course lead Zora is trying to develop these labs accordingly, and she's consulting with the different instructors about it. And as we get them, we will post it for you. So in general, we will post the lab. You'll have it in a certain week, and then you'll have essentially until Tuesday of the week after to submit it by 5 p.m. to submit your report by 5 p.m. The way you submit your report is I will upload the lab, the actual lab document in Word document, so you'll be able to personalize it and write your information and all that. You could type it, or you could print it if you have access to a printer, or you could just simply enter your data one way or another. And then once you do that, if you're doing simulations, you'll get graphs. You'll be able to attach the pictures, the graphics of your graphs in that report. And then you save it to PDF and you upload it as assignment on SLATE. So I'll explain all that later on, but essentially that's the bulk of it. So whenever we give you a lab in a certain week, it will be due the week after on Tuesday. I already entered the deadlines for all the labs on SLATE, so you have it over there. Missed evaluation. This is, I think, common knowledge. Many of you know the process of missed evaluation at Sheridan, but I simply wanted to go through it just in case some may have forgotten what it is, or there's always one or two students that will always come in and ask questions regarding to missed evaluation. So I'll just want it to be very clear with everybody. So if you miss any evaluation, whether they're labs, quizzes, midterm, or final, my responsibility as a faculty member is to give you 0. Now, I'm not trying to be mean or anything. This is just the way we operate. If any evaluation is missed, automatically our job in duty is to give you 0. Now, you may have legitimate reasons why you missed it, and that's okay. So for instance, if you had some emergency, then initially we'll give you a 0. You go through the process, and then that 0 will be replaced, and then we'll find ways of how you could redo the test. But in general, we give you 0. Then you, so what do you typically need to do? If it's an emergency, you need to contact the department, the MEET department, within 48 hours. If it's a non-emergency and you know you're going to miss an evaluation, you need to contact the department 1 week in advance. Now, these are the phones to contact them. So you have the extension here, and you also have the email here. So depending on which one is easier for you to get, you could use one or the other. Email is always good, but if it's very urgent, you could also call. So once this is done, then the process essentially requires that you fill a missed evaluation form. So these forms, they exist, and then the department, they will walk you through the steps of what you need to fill. And you also need to fill or they're going to fill, with your help, a verification of student illness or injury. And once this is done and the associate dean approves it, then we'll find ways for you to redo the evaluation that you missed, and eventually the grade that you got here, the 0, will be removed if all this is processed and is approved by the school, our MEET school. So this is the process for a missed evaluation. If you get a 0, just know that you get that because I'm following the rules here, and we cannot do anything else outside these rules. Okay. By the way, all this is available on SLATE, so you'll be access all this on your SLATE for students. All that this is available there. Weekly timetable. So what are we gonna do in every week? So this is what we have. So we have a table of weekly timetable. So we try to put it in a very coherent way so you know what you're gonna do in every single week. And essentially what we could observe is that the first part is 6 weeks. The second part, you'll have your break, and then the second part is 6 weeks. This might be a bit too small, so I did also put these tables in your class plan, and also on the first page of SLATE once you log in. But in general, what you observe is that you have a quiz here, you have another quiz here, you have your midterm, you have a fourth quiz, you have your final, you have lab 1, this counts, lab 2, lab 3, lab 4, lab 5, 6, 7, and 8. And here you have your reading week, which is off for a week. So the first half is essentially 50% of your semester, and the second half is also 50% of the semester. So with me, you will cover this part here. And most of the stuff that we will cover here is analog, and most of the stuff that you will cover here is digital communication. So this is where we are right now. So we'll give you some, so I'll just explain some of these concepts very briefly in this lecture, and whatever is left, we'll just push it to the next lecture and we'll move on. Now, this is a timetable that we condensed based on 14 weeks. So we are trying our best to cover as much as possible, but we'll see how this will be done. If it's something that we won't cover in the lecture, then certainly this will not show up on your evaluation. But if we do cover it in the lecture, it will show up on your evaluation. Okay. Now this is, I think this kind of goes along with what I just said. So small variations are normal to accommodate pace of students, unforeseen circumstances, and so on. So one major unforeseen circumstances is that we will have less lecture time days than expected. So in reality, 10 lectures, 1 midterm and 1 final. So yeah, so we'll see how that goes. The textbook. So we decided. So this is really a decision by the course lead, which is her. And I was in discussion with her. We decided to essentially come up with 3 books that we will use in this course. And the decision with these textbook is that we wanted to put less pressure on you because we know that it could be difficult financially. So these 3 textbooks that we have is this one here. This is a textbook that was published in 2018. This is another 2018. This is another textbook in 2016, and this is a 3rd textbook in 2015. So all these 3 books, we are actually fortunate to have them as part of the Sheridan library, right? So Sheridan paid for them. So for you, you'll be able to access them essentially free of charge. So you don't need to pay anything. This you could access and read it online. So it's going to open on a browser, and then you'll be able to read the sections and chapters. This is the PDFs of every chapter that you'll be able to download, and this is the same. So why are we using 3? Is because there's no perfect book. So some books are strong in certain areas and others in others. So we'll use 3, and it's a good way to mix and match and see how the different perspective in explaining the same concepts, or to complement each other. So different books will complement each other. They have different styles, and you'll have the option to move between them. They are available free of charge for you. Once you go in here, you click on it, it will allow you to go to the library page, and then you could just put in your Sheridan credentials to access them. And I think I put some of them on SLATE, so you'll be able to see it in the references, a book. Okay. Now, one thing that is also important to remark is that textbooks will be used for independent study. So lab, quizzes, midterm, and final may include references from these required sources. So this is just something that you should know. Okay, finally we reach the slide which I want to talk about your future. So my objective as your professor in this course is to guide you technically to understand the basics of telecommunication engineering, and specifically at the system level. So in communications in general, there are different ways of looking at them. Somebody could be working in telecommunications, but they could be looking at it from an upper layer perspective, or essentially on the application layer. So the people that are in, let's say, applied computing, the folks at Trafalgar, the folks over there, they look at it from an upper layer application point of view, whereas us engineering folks, we look at it from a lower layer point of view. lower layers point of view means that we are closer to the hardware component of a telecommunication device. And so really that's what it means. And in reality, there are different also within the lower layer. One could look at it from a network layer, and that's mostly the people in computers, computer science, and in fact computer engineering as well. Whereas for us, for electrical engineers, we look at it from the link layer, and that's really the lower, very lower layer, the physical layer, and then the MAC layer. So all this is explained in the OSI model. I'm not sure if you've seen this in other courses, but that's kind of part of the OSI courses. So people in electrical engineering, you guys, you will look at it from a physical layer and from a MAC layer, so the link layer. People in computer engineering, they will look at it from a MAC layer and network layer. And people in applied computing, they will look at it from an application layer, upper layers. So that's kind of my objective, is to introduce you to these concepts, to introduce you to some of the basics of these topics. Your objective is to learn communication engineering fundamentals and skills, and to connect what you learn to real-world applications. Do not underestimate fundamentals. Quite often people, as they advance in a field and they work, their knowledge becomes a bit shaky because the fundamentals are missing. So understanding the basic fundamentals is extremely important. No matter how advanced the system you're working on, if the fundamentals is shaky, you don't have a good grasp of it, it will be very hard to understand. So let's say if we talk about 5G communications and you don't understand the basic fundamentals of communications, it would totally not make any sense, right? So all the complications of modern telecommunication systems, they always build on fundamentals. So understanding the basic fundamentals is very important, and therefore I think you need to grasp all that. Now, certainly that we are looking at it in the first half, at least, on analog communication, and it could be argued analog is a bit outdated. Why are we doing that? But I think in reality, you will not appreciate digital communication without really seeing analog communication. So we are devoting the first half on it, just to get a good sense of that. And it also, in analog communication, it will also be a good learning experience for you to understand how signals are processed. So this falls under the area of digital signal processing. So how do signals change form from one state to another? What happens to signals as they travel from here to there, as they go from one input to a system, to the output of another system? These are all parts of DSP, digital signal processing. So there's some benefit as well at looking at analog communication. So don't underestimate that. Now, so you're now in communication systems course. You'll be spending 12 weeks with myself and other instructors, and hopefully you do well in class. You will go through the lectures. You will try to read the book, or at least go through some of the topics within the book. Try to do all the assignment problems, and to take the assignment problems seriously. You'll be able to come into the virtual classroom and interact and ask questions. And as you do all that, you will essentially get a new tool that you can add to your toolbox. So every course that you took at Sheridan is a tool that you're adding to your toolbox, and this is another one that you're adding there. And hopefully this will eventually help you when you go look for a job once you graduate. Some of you are graduating soon, others you still have some semesters to go, but that's that. Now I know the state of the economy is not great right now, but just realize that it will pick up once the situation improves, and just by looking at 5G communications and IoT, it's a huge market, right? So you have these numbers, 40 billion in terms of incremental GDP to the Canadian economy, 250,000 jobs just from 5G, and so on. So this is a big area. Of course, 5G is just one element of telecommunication, but it will be huge, and it will take it will be, you know, a lot of sectors will be somehow impacted by 5G communications. So there's a lot of jobs in this area, and in order to work in 5G, you really need to understand the communication engineering fundamentals, skills, system level. All this stuff will be useful for you. 5G is not the only area where generally people work. You could also end up working in IoT. So IoT is a huge area as well. In fact, IoT is also part of 5G. So not always, but sometimes. So the future is good in telecommunication, and I think whatever you learn here will eventually be useful for you. Okay, so now I'll just try to cover some of the topics that we have for lecture 1, and we'll start with that on the next slide. So for the remaining slides, I wanted to cover a bit the history of telecommunications. Show you a block diagram for communication. So, you know, if you have a complicated communication system, can we boil it down to various subunits, subsystems in a nice block diagram in a coherent way? And the answer is yes. And so how does it work, and what are the different components? I want to show you that. And touch on the electromagnetic spectrum, so you get familiar to it. The spectrum becomes important if we talk of wireless technologies. So when we say telecommunications, the communication could be wired, or it could be wireless, right? So if the spectrum becomes important, the electromagnetic spectrum becomes important when we talk about wireless communications. For wired, the spectrum is not, you're still transmitting on a frequency, but you're not using the spectrum. You're not using the spectrum over the air. So that's the difference. It's guided in a wire. So that's the difference. So I want to explain a bit of that, and then some of the applications. So we'll see how much time we have left for here. If we don't have enough time to cover everything, I'll push it to the next lecture. Okay, so in general, maybe I should also mention timing. So in general, as you know, in classes, I try to keep my lectures to 1 hour and 30, 1 hour and 40 minutes, because we give time for break. And so when we make the video, I'll try to kind of follow the same thing. Although some might say we could keep it a bit shorter because there is no interaction with students, and that adds to time. But I'll try to keep it to 1 hour and a half per lecture. Okay, let's move on. Now, before we move on, I wanted to show you a short video. It's a 3-minute video, so I want you to see it. It's made from HP, and then I'll add some comments on it.
Long before telecommunications was even a word, humanity was obsessed with its central concept, long-distance communication. Some 40,000 years ago, the earliest methods of relaying messages consisted of smoke signals. Homer wrote about the early Greeks' use of fire in the Iliad, and drumming, very loud drumming. This was used in Africa and Asia. Although primitive, these approaches were inventive at the time, relying on coded language. Certainly, there were other clever approaches through the centuries. The Greeks' carrier pigeons, the use of ravens in medieval times. But the real breakthrough came in 1451 with the advent of mass communication. Johann Gutenberg, a German goldsmith, invented the printing press. It replaced monks and scribes duplicating documents painstakingly by hand. The technology introduced concepts that we associate with the internet today: a one-to-many mode of communication, widespread access to knowledge, mobile information. The history of telecommunications is a story of evolution, and often, as in other industries, progress was incremental, inventions built on earlier ideas. In the 1790s, for instance, French engineer Claude Chappe built the first telegraphy system. For the 136 miles between Lille and Paris, stone towers were constructed as far apart as 20 miles and used to relay flag-based messages. Electricity changed everything. 50 years after Chappe, Samuel Morse and his colleagues created the telegraph. It relayed electrical impulses, Morse code, the descendant of those early smoke signals and drums, over wires. Soon, those wires extended across the country and even under the ocean, instant long-distance communication was finally a reality. The telephone, invented in 1876, became a household device in the 1940s. It made telecommunications personal. Alexander Graham Bell's invention transmitted the human voice, in the early days multiple voices, over shared party lines. The journey to modern telecommunications is punctuated not only with major milestones, but also with ideas that were ahead of their time. For instance, Bell's wireless telephone call in 1880. That breakthrough didn't catch on right away, but it eventually led to today's fiber optics. If the first 40,000 years were a methodical climb, the last 30 years have been a sprint. From the internet to smartphones to wearables, from email to texting to video chat. We all know this most recent chapter. We've lived it. What we may not have noticed, though, is how telecommunications has shifted yet again, from communication between humans to communication between machines. We live in a world where internet-connected devices are constantly talking to each other. More often than not, they're talking about us.
Now that we just saw this interesting video, it's a 3-minute video, but it gives us a gist of some of the background of telecommunications. I just wanted to add some comments. This is another image that I took from this website, and it's also interesting. It kind of gives you a summary as well of the different evolution of communications, how it went from a very basic approach, such as a smoke signal that was used to convey some coded message, all the way to what we have now with a smartphone. So you see there is an evolution. Now, of course, this image is not comprehensive. There's a lot of other technologies that came between various technologies throughout this timeline. But I just wanted to comment a bit on the video, so we add some context as well. So, for instance, smoke signals. That's very interesting. So that's one way of conveying information. And in the end, telecommunication is all about communicating and sending information from one point to another. So you're trying to be at a communication with another entity that is apart. They're not necessarily close. So there's some separation between you and whoever is receiving your signal. So eventually it moved into the carrier pigeon that was used by the Greeks, and a major breakthrough was with Morse code. Right? So Morse code was invented by Samuel Morse, and essentially this the technology around Morse code is referred to as the telegraph. And the telegraph is based on sending messages, based on sending impulses, electrical impulses. So if you see this is referred to as dot, and this is referred to as dash. So you send two type of information, dot and dash, and based on a certain combination, this corresponds to a certain letter. So every letter that you have in the alphabet has a corresponding a sequence of dot and dashes. So it goes all the way to Z, including the numbers. So if you look at it, this actually resembles what we now use as digital information, as binary information, zeros and one. So dot and dashes are kind of the precursor to what we use today as zeros and one. So it was very brilliant and smart, and this was around 1847. Eventually we moved to radio, and so I have to say that Morse code was based on a wired connectivity. So every other point that was receiving the Morse code, the Morse signal, it was conveyed through wires. So everything was wired. Whereas radio is suddenly it becomes wireless. So you have an analog signal that is sent to you from from a tower, and you have a device, and in your device you're able to receive the signal. So the tower broadcasts the signal, and you as a person with a receiver, a radio device, you're able to receive this signal, and this is an analog signal. I guess the key person in radio communication is the Italian electrical engineer Guglielmo Marconi, and he was kind of the father of radio communication. The telephone was also very important. So the telephone, mostly wired, but also the Alexander Bell worked on some of the wireless technologies there. But in general, this was a major breakthrough that happened around 1876 in the U.S. by Alexander Bell. And I guess we could move on all the way to the concept of cellular communication. The concept of cellular communication, or sometimes we refer to as mobile telephony or mobile communication, could trace back to 1946 at AT&T and Motorola in the U.S. So that's the whole idea began there. It is kind of controversial. Different people will say that they are the major founders, but I think attributing to this technology to AT&T and Motorola makes sense. Although some work was also done in Europe, particularly in Scandinavia. One should also be reminded that while this was happening in AT&T in 1946, the year after, 1947, also at AT&T, the transistor was discovered. So this was in 1947. So the role of electronics facilitated the whole process of building devices, because these telecommunication devices, they're built from electronics, and the electronics that you have from these devices onward, they all have transistors, and transistors came about around the same time. So the cellular concept was invented in 1946. 1947, the transistor came about, also at the same company, at AT&T. And what's remarkable is that the year after, in 1948, also a guy from AT&T, Claude Elwood Shannon, so he publishes his famous paper on information theory. And then suddenly in 1948, the whole concept of digital communication exists. Before 1948, we did not have the concept of digital communication. All type of communication that we had, electrical communication, that is, not smoke signal or pigeons, they're all based on analog communication. So Claude Shannon was a major person in moving us from a bad, poor performing analog communication to an excellent, good performing, smart digital communication approach. And also, I have to also say that Shannon was also instrumental in developing Boolean theory, and he did that in 1937. So he's a brilliant guy. He's, for us, he's considered the father of the information age, Claude Elwood Shannon. So that's 1948. So if you see this company, AT&T, they did a lot within a 3-year period. 46 cellular system, 47 transistor, 48 digital communication came from that company. Now, another landmark that is not shown here is satellite communication. So the USSR, so the former, the Soviet Union, what is now known as Russia in the neighboring countries, launched their first satellite in 1957. That was a major breakthrough. So suddenly we are using communication not in any devices that are close to us, but really in space, in outer space. And that was very important, because outer space, we use satellites because the reach becomes more important. There's delay when you transmit with satellites, but you have a greater coverage region with satellites. So that all happened in 1957. The internet, with ARPANET, that was around 1969. That was kind of the precursor to the internet. And then many other technologies. One technology that I'm familiar with is Bluetooth. That was invented in 1994 by researchers at Ericsson in Sweden. And then there's other technologies. And today where we are in 2020, everybody's talking about 5G. So 5G is a major technology that we have. And of course, 5G came from 1G, 2G, 3G, 4G, and 5G. But it is it is a paradigm shift from all the other Gs. So that's a major technology that we have right now, and there are others. So maybe the question is, what do we expect to have after? I mean, if you see the history of where telecommunication is, what is the future? Nobody really knows, but there are certain hints on what technology might be. And certainly one of the some of the different applications for the future are connected and autonomous vehicle. These are devices and systems that we are expecting to have more on in the coming very soon. So these devices, they rely on such technologies as AI and machine learning, but also on connectivity. You also have VR, virtual reality, and augmented reality. So this will also be major in very soon in the next couple of years as well. So this is where we are seeing the future, but there are way more technologies, and you'll be part of this future of telecommunications. So this is kind of a brief overview of the history of telecommunication. I hope you got some key ideas, yeah. So I kind of give you a context of telecommunication. Let's move on to the next slide. Okay, so now that we have some sense, at least some historical sense of what communications is, telecommunications that is, where it began and how it evolved, from a smoke signal into an electrical signal that is sent in the air in a wireless fashion. We want to kind of explain some of the concepts behind communication in a more concrete way. So the question that we ask is, what is communications? Right? So that's just kind of the question that one would ask when one is trying to study telecommunication. What is communications, right? So communication, it is the process of exchanging information. If you boil it down and you want to say something very condensed, I think this is a fair statement. So it's just the process of exchanging information. You have some information, you want to send it somewhere else. Okay, so verbal communication is one way of communicating. So you would talk and you interact that way. That's one way of communicating. Non-verbal communication, your expression, your facial expression. If you're sad, if you're angry, if you're surprised, if you're neutral, if you're bored, all of that would appear just on our face, and humans are developed to actually detect different signals in a non-verbal way. So there's no communication, but just by looking at somebody as you're interacting with them, you could get a sense of where they are with this interaction. This could be a bit far-fetched and kind of funny, but telepathic communication, some people believe it, but it's the whole idea of putting a thought from one person to another. Now, this is also if you will, it's a form of communication. Again, it's a far-fetched assumption, but nonetheless, it's there. Written communication, of course, that's a very classic way of communicating. So written communication or typing, anything that is in a written format, that's another form of communication that you could have. And this is kind of an advanced form of written communication, electronic communication, like emails and word processing and documents that you do with the computer. That's kind of an evolution of written communication. So if we look at it, this is what communication is. So many of these concepts are concepts that I teach when I teach technical writing and presentation. I talk about some of these topics. So I look at communication from that perspective, but here I look at communication from an electrical engineering perspective. So that's where the difference is. From an electrical engineering perspective, we now refer to it no longer as communication, we refer to it as telecommunication. So telecommunication, it is the process of exchanging information at a distance using electrical devices. So I think the key thing to take here is the word electrical, right? So we are using electrical signals in communicating information. So you're sending a signal that has a certain voltage, a certain frequency, a certain amplitude, and you're using that to convey your information, or a certain current, right? It could be voltage or current. And this is where the word telecommunication become important. Sometimes we don't say the word telecommunications fully. We just chop it down to telecom. That's also fine. So you might hear that. That's okay. But from an electrical engineering perspective, sometimes we also use the word communication to refer to telecommunications. So you have to be careful. So if you hear the word communication and you're speaking to an electrical engineer, a communication engineer, it's probably the more accurate terminology is telecommunications. Okay? So now what is interesting to highlight here is the fact that the prefix tele, it means at a distance. This is a Greek prefix, and the word tele, it means at a distance. So television, so it's sending video or vision at a distance. Telepathy, again, you're sending thoughts at a distance, and so on and so forth. So tele is used in this context. So that's what it means. Now, the other thing that we want to highlight is what are the different type of information that you would convey in an electrical form. So if you bring it down and you boil it down, there are really a handful of things that you can send in an electrical signal. One form of sending information is audio signal. So you have an audio signal and you're sending that, right? So if you're speaking on a phone, on your cell phone, and you're talking to somebody else on the other side of the planet, and they have a cell phone, you're sending an audio signal. So your signal that is coming from your mouth, it changes, it moves from an analog signal that is coming from your mouth, it changes into a digital signal. That signal is then modulated, it is sent into the channel, and then the other person would get it. So that's an audio signal. That's one form of an electrical signal. Another form of an electrical signal that you could transmit or to somebody else is a still image. So it's just an image that you would send to somebody else. Another form of information that you could send is a video. So a video is basically an image with different snapshots. Snapshots that are placed one after the other, and every snapshot happens at a certain time. And so basically a collection of images over time becomes a video, and that's another form of information that you could send. And the fourth type of information that you could send electronically is electronic data. So any type of data that is generated using some computer system. So that's another form of information. So if you bring down all the different communications that we do with our modern systems, it's really that. It's audio, it's image, it's video, and it's electronic data. Okay, so I hope that kind of gives you some actual context of what do we mean by communications, what do we mean by telecommunications, and so on and so forth. Now, for electrical engineers, again, I need to emphasize that we do use interchangeably these terminologies. Communications and telecommunications, we use them, we consider them to be the same, but if you dig deep in it, they're different. They're not the same. This is meant in a general sense all these different type of communication, whereas this is really meant for electrical signals and electrical devices that convey information. But for, just so you know, it is common to use them interchangeably, and sometimes we also chop this to telecom. That's also possible as well. Okay, let's move on to the next slide. So in here, my interest is to show you the different elements and the different components of a telecommunication system. So if we have a telecommunication system, the question that we could ask is, can we put it in some block diagram, some logical way to comprehend how a telecommunication system operates? So you could think about it. The short answer could be yes, certainly we can do that, right? So when you communicate, there's always a node that transmits, and there's always some node that receives. So there's some logical organization within that, and we could look at it in that perspective. And so we could put it in a block diagram. But before we do that, I just wanted to kind of explain some example. So the example that I'd like to show you here is the tin can telephone. So essentially what it is that you have a metallic can, basically that you have, and you put some vibrating element between them, and as you talk, the vibration will go, the signal of your mouth, it will vibrate the string, and essentially the other person could hear your signal. So this is a toy that typically people, younger kids would experiment with in schools. I remember I did this when I was in primary school in Montreal. So if you look at this by itself, this is a very basic communication system. So there are various components within this. The first component that we see is there's a source. There is an agent, a device that is generating a signal, some information. So the source in this case that is generating the information is this person here. This person here is the source of the information. So this person here comes up with some information. He's saying it in his mouth, and this is referred to as the source. The destination is whoever is receiving the information that is being conveyed. So this is a destination. So it's this person here that is receiving the information that is conveyed from the source. Okay, so that's the destination. What else do we see here is we could also identify this device, right? This device is we refer to it as TX. TX is a shorthand notation for transmitter. So some people put large T, large X, or large T, small x. So essentially it's just a shorthand notation that electrical engineers use to refer to a transmitter. So you can think of this can used by this person as the transmitter, and therefore this can we could also see that it's referred to as RX, the can used by the destination, and this is essentially the more technical word that we use in electrical engineering is RX, or receiver. So if you want to say receiver, but you want to say it in shorthand notation, we just write it as large R, small x. Okay. So you have the source that generates the signal. You have the transmitter, the device that will send the signal from the source. You have the receiver, the device that will receive the signal from the transmitter, and the destination, the actual entity that is the node that is detecting your signal. Okay. The other key things that we should highlight here is that there is, of course, the medium that you have between the transmitter and receiver. So this is referred to as the channel. In this case, it is this string, and this string is the channel. This is what happens between the transmitter and the receiver. So in wireless communication, the channels is essentially the air, right? So your signal will travel in the air, right? So that's over the air. So that's your channel. And in wired communication, it would be whatever type of technology you're using. So for instance, in a wired communication, you could think of the coaxial cable. So if you're using a coaxial cable, that could be your channel. If you're using fiber optics, then that is your channel. You're using a fiber optic channel. If you're using a Ethernet with an RJ46, that's your channel, or an RJ11, then that is your channel, right? So it depends on the type of medium that you use. So if you use a wire, that's your channel. If you use wireless over the air, then that is your channel. In this case, this string is the channel. So here I kind of put the explanations that I said earlier, TX for transmitter, RX for receiver. And I also wrote to you here that all systems have these fundamental communication elements. So any type of telecommunication system will have a source, it will have a destination, it will have a transmitter, it will have a receiver, in a channel. So if you don't like to remember source and destination, you could just remember these three elements. There's a transmitter, there's a receiver, and what is in between them is the channel. Okay. So now let's look at it from a more technical way, an approach with block diagram in a convention that is typically used by telecom engineers. So block diagram of communications, or if we want to be more precise, telecommunications, is as follows. So you have some input data, right? Whatever the data is, it could be some signal that you have. It could be some voice. It could be some information that you want to convey. The data could be analog. It could be digital. It could be continuous in the time domain. It could be discrete in the time domain. Does not matter. It's just some data that you have. And this data that you have, you want to transmit it. So before you transmit the data, so this data will essentially go into a box. This box is your transmitter, right? So it's your TX. What the key point of a transmitter is that the transmitter will take your signal. This is your input data is essentially a signal. This is a signal with some voltage, some current. So this is a signal. It would enter a system. The system will modify the signal. So it will do some DSP. It will modify the signal, and this modification happens at the transmitter. And then this signal is we have a terminology for it, so we call it the signal will be modulated. So, I mean, what do we mean by modulation? Modulation, if you want to just kind of look at it from a basic explanation, is just taking some information and then changing it, and modifying it, right? So you have some signal here, you put it into this box, and then the signal that you inputted will be modified. So what the modulation does is that in a communication perspective, in a telecommunication perspective, it will move the signal from a low frequency, from operating at a very low frequency in the baseband into operating in the passband. So it will increase the frequency of it. We call this as up conversion. That's what it is, okay? Then the modulated signal will go through the medium, whatever the medium is. If we are talking about a wireless channel, then the channel will add, things that we don't want, essentially junk. And the junk that is added in the channel could be noise. It could be fading. Fading is all the power loss that happens between transmitter and receiver, and interference. There are other sources as well. I talk more on them, more on these elements in the wireless communication course on what happens in the channel. But not here. I think it's too advanced for this course. But in general, there are all the bad stuff that happens in the channel. So that's the channel will essentially deteriorate your input signal. The signal here will be deteriorated in the channel. Okay. And then essentially the signal that goes through the channel will be detected at the receiver, and the receiver, what it does is it demodulates. So it brings it back into lower frequency, And when you get it in lower frequency, you get your output data. So this essentially, you are expecting this to look more or less like this one, and you're expecting that whatever you see here to look more or less like this one here. But of course, this will not happen. And the key reason why you will never get exactly what you transmitted, it's because of the channel. The channel will will deteriorate the quality of your signal. And it's all about the channel. Whatever happens in the channel, this is kind of the most harmful way, the most deteriorating factor in a communication. It's the channel. It will modify your signal. If we had an ideal channel, then whatever you transmit is whatever you get. But that's not the case, right? And if you look at the picture here, we have the source here, and in this block diagram, this is the source. We have the destination here. In this diagram, this is the destination. Now, I need to explain perhaps more that what you get after the transmitter is referred to as the transmitted or the modulated signal. So the signal at a higher frequency, whereas this is a signal at a lower frequency. And then what you get at the input of the receiver is essentially referred to as the receive signal. Right? So that's kind of common sense, but that's the terminology that we use. Now, one thing that you should realize, like I said earlier, is that the signal that you have here is a noisy version of the modulated signal. So whatever you get here, you don't necessarily get it here, but you get a noisy version of it. Whatever the modulation approach that we use, irrespective of that, due to the channel, you'll get a noisy version. Noise also exists, by the way, with wires. When you transmit a signal, and let's say you use an Ethernet cable, your signal will travel through an Ethernet cable, but then depending on the length of your cable, you will have a loss in the channel. You will lose some dBs because your cable, let's say, is too long. There's going to be losses, and there's going to be resistance in the wire, so you will lose power. So losses happen everywhere, mostly in a wireless channel, but even in wire channels, you will have losses. But if you compare, let's say, wire channel versus wireless channels have greater losses. The signal loses very quickly because it's not guided. Your signal that you're sending is not in a specific environment. It's in the air, and it could bounce up everywhere. Whereas in a wire, it is guided. It knows it has to follow the path of that conductor within the wire and the jacket around it. So that's just some stuff to kind of be careful with. What we refer to what we get at the output is a detected data. So basically, this is the input data. This is a detected data, and it's a noisy version of the input data. So it's not quite this, but it's a noisy version of it. So if you're, let's say, sending a digital signal, you send a stream of zeros and one. Here you will detect your zeros and one, but not quite the same. Some of them will be in error. If you are sending an analog signal, you're sending some signal that varies over time with various values of voltages or current, then what you get here will be perhaps an attenuated version of it. Certainly it will be attenuated, and it will also be corrupted, and it's corrupted because of noise. And we'll see examples of that when we look at AM and FM later on in the course. AM and FM signals later on in the course. Okay, one other thing that terminologies that I should mention is baseband. So when we generally look at signals entering a modulator, we refer to them as baseband signals. Signals that are operating near they have a center frequency around the origin. And signals that operate after the transmitter, they are referred to as passband signals. And of course, since you're still in the channel, your signal that you detect at the receiver is also a passband signal, and the signal that you get at the output is a baseband signal.